Welcome for mathematics lesson. We're going to do transformations. Number 24, where we are told that the coordinates of a triangle ABC are A11, B31, and C13. Part A, plot the triangle ABC on the grid provided. So on this grid, we're going to plot the triangle ABC, whereby A is 1, 1. So 1 against 1. This is the point A. Then B is 3, 1, 3, 1. That is where B is. Then C is 1, 3. This is where C is going to be. So I can now join A to B, B to C, so that I may get my triangle. So this is my triangle now, plotted. Part B, triangle ABC undergoes a translation vector 2, 2. Obtain A prime, B prime, C prime, the image of ABC under the transformation, then write the coordinates of ABC prime. So for us to have the triangle undergoing a translation, then we're going to carry out the transformation. Remember, the vector is 2, 2. Therefore, with 2, 2, we are going to carry out the transformation for each coordinate. So translation 2, 2, it means for A, we're going to move 2 to the right and 2 upwards because the vector is 2, 2. Therefore, 2 in the X, 2 in the Y, and it is positive. So it is to the right, and this one, it is upwards. So if it were negative, we could have gone to the left. And if it were negative for the Y component, we could have gone downwards. Therefore, from A, we go 1, 2, then again 1, 2. So this is where A is going to be located. The image now, A prime. Then B, we're going to have from B, 1, 2, then upwards, 1, 2. So this is where the new B is going to be, the new point or the new position. Then C, from C, 1, 2, then upwards, 1, 2. So that is where C prime is going to be. Again, I connect now the coordinates using a straight ruler to get the triangle. Yes, that is now the translated triangle. After the translation, we are going to state the coordinates. A is going to be 3, 3. So A prime is 3, 3. B prime is going to be 5, 3. C prime is going to be 3, 5. So 3, 5. That is how the coordinates are going to be. Part C, ABC prime undergoes a reflection. The line x equals to 0 to obtain A double prime, B double prime, C double prime. On the same pair of axes, plot A, B, C double prime and state its coordinates. Therefore, we're now going to plot A, B, C double prime. After reflection, line x equals to 0. So line x equals to 0. This is the value of 0. Therefore, when we draw a line at this point x equals to 0, we're going to realize that line x equals to 0 is the y-axis. So we're going to reflect this first image along the y-axis, which is line x equals to 0. Therefore, because the line is very vertical, we're just going to take A an equal distance from the mirror line to the other side. So we have 1, 2, 3 squares. So 1, 2, 3 squares. This is going to be our A double prime. Then for B now, whereby we have 1, 2, 3, 4, 5. We move 5 to the other side for 5. So this is where B is going to be double prime. Then C, which is 3 units away, it's going to be 3 units from the mirror line. Remember, for reflection, the far a point is from the mirror line, the far its image should be on the other side of the mirror line. So if from the mirror line, B is the farthest from the mirror line, B double prime should also appear to be the farthest. So that is how we reflect when the line is very vertical. Yes, that is now the image. Because we are again told to state the coordinates, we're going to have A being -3, 3. So A double prime is going to be 3, negative, 3 positive. B double prime is going to be -5, positive 3, -5, positive 3. C double prime is going to be -3, positive 5, -3, positive 5. We continue. A double prime, B double prime, C double prime undergoes an enlargement, scale factor -1, and center 0, 0 to obtain ABC triple prime. Draw triangle ABC triple prime, triple prime. Therefore, for us to carry out an enlargement, scale factor -1 and center 0, 0, we should remember that with a negative scale factor, object and image are on opposite sides of the center. For example, if we are enlarging A, we'll stand at A and we connect it with the center, which is 0, 0, the origin. Yeah, to move to the other side, like that. Therefore, because the scale factor is -1, we are going to move only once. So from the center of enlargement to where A is, we lift that distance and we move an equal distance to the other side, and that becomes our A triple prime. We do the same for the other coordinates. For instance, we have C here. So we connect C to the center of enlargement. C to the center of enlargement. Then now we again lift the distance from center to where C is. Then we transfer that distance to this side, and this is going to give us where C double prime, triple prime is going to be. And finally, we are having our B. So we join B to center, join B to the center. B to the center. Then we move to the other side, an equal distance from center to B. Then we carry the distance to this other side. So at this point, we're going to have our B triple prime. Now we can complete by joining the coordinates. So this is the third image. Now we have another statement here. Okay, for that part, we've not been told to state coordinates, but in case you want them, you can just extract them from the diagram. Part E, describe fully the transformation that maps triangle ABC, the fourth image, with coordinates -3, -3, -3, -5, and -5, -3 onto triangle A triple prime, B triple prime, and C triple prime. So we're going now to plot this other triangle, the fourth image, -3, -3, -3, -3. So back to the triangle, back to the Cartesian plane, -3, -3. This is where A is, the fourth image. Then B, -3, -5, -3, -5. This is where B, the fourth image, is. Then C is -5, -3. -5, -3. This is where C, the fourth image, is. So this is now the triangle. This is the triangle. This is the triangle. Now the examiner is telling us to identify the transformation that will map this fourth image to the third image. This is the fourth image of the triangle to the third image of the triangle. We cannot describe a transformation by just observing with our naked eyes. What we need to do is to construct. So we can start by connecting A to A prime, A to A prime. Then now we bisect the line connecting A to A prime. Sorry, let me connect this one. Yeah. So standing here, I'm going to bisect that line which connects A and the image. So this is the line. The axis is still the bisector, that one. And we also connect B to B prime. B to B prime. So from B to B prime, connected. Then again we bisect this line connecting B and B prime. So standing at B, I'm going to make some arcs. Yeah. Then standing at the other B, I cut those particular arcs. Then I join to know the bisector of the line joining B and B prime. You know, I'm realizing that the bisectors, these perpendicular bisectors now, these perpendicular bisectors of the lines joining A and A prime, B and B prime, they are all meeting at the origin. They are all meeting at the origin. If the bisector was the same, if we realized that when we bisect this line connecting B's and the line connecting A's, if we bisect them, we were getting the same line, then we would conclude that it is a reflection. But now we are concluding that the lines are different, but they have a common point of meeting. Let us try C, the third point, C and the other C, C and C. Yeah, then now we bisect the line connecting C and C prime. So standing at this other C, we can make some arcs. Then we stand here to cut those arcs. Make an arc there and an arc here. Then we join. Yes, we join this arc and this arc, and it is confirming to still be passing through the origin. Therefore, we can conclude that this transformation is a rotation. It is a rotation. The transformation here, we are taught to describe it fully. It is a rotation. To fully describe a transformation, for example, a rotation, we need to mention that it is a rotation. Then we also mention the center of the rotation. So the center of the rotation is the common point where the lines are meeting, origin. Then now we also mention the angle of rotation and the direction of rotation. Therefore, for us to identify direction and angle, we need now to connect, if it is A to the center, we connect A to the center. The center has already been identified. Then we connect again now from center to the image. Remember, we are looking for a transformation that will map the fourth image back to the third. Therefore, from this fourth image to the third image, we have identified the center, and we can see the turning here was of 90 degrees, as it can be confirmed with a protractor. 90 degrees. And according to this turning, we are turning in the anti-clockwise direction. So if an angle is measured in the anti-clockwise direction, it is given a positive sign. So we'll say it is positive 90 degrees. So rotation, center 0, 0, angle positive 90. We can confirm the same. That was A. We can confirm the same using maybe C. We can connect C to the center. C to the center. Then from center to the image we want. Yeah, from center to the image of C. So we can see from C to center, then from center now to the image. The angle is of 90 degrees and it has been measured through the anti-clockwise direction. So it is positive 90. When we use B, we are all going to confirm that the angle is positive 90 degrees and the transformation is a rotation. Thank you for following. Subscribe and share.